Hello. It's great to be back at a conference with people and all that. It's still a bit awkward, but it's also great. So I'm really happy to be here today. We've just given a presentation, Rahul and I, yesterday at the Android Dev Summit, which is why we have the slides from this. But we extended from those slides. Who of you has seen the presentation that we called Back to the Foreground already? I'm very happy because you will all be surprised that it's different from the one that we have recorded. It's longer, it's more in depth, and we might have some room for questions in the end. And also, because of technical limitations, it's without speaker notes, so it's going to be way more fun because we're kind of, well, less prepared. It's not true. We're still very prepared, but kind of not got stuff to read on. Rahul has been in charge of WorkManager for a long time, and he will talk about a couple of really nice in-depth things, and I will be talking about a couple of other things that we haven't talked about before. And with that, let's show you how to get back to the foreground with WorkManager and Android 12 and be future compatible with that as well. Or not. Yeah, if I don't plug that in, it doesn't work. Ha! I haven't been at a conference in a long time. Have I said that? So just give me a second. There we go. So WorkManager has been around for a while now. We introduced it at I/O in 2018. And at that time, we had several foundational APIs that were there from the beginning. And one of the things that WorkManager did was it allowed you to run work deferred. Deferred means not now, but later. So I'm not an English native speaker, so some of those concepts are kind of not really very obvious to me because I'm, well, German. We've got different words for that. But deferrable means that it runs later on, and it's not 100% clear that it runs at an exact time. And that concept was a bit confusing in the day. It's great now because it actually means it's fine. It doesn't really have to run at a specific time. If you've done things like syncing with a server, back in the day you were saying, well, I'll set my server sync to run at midnight because that's usually when my users sleep. And have you ever had a server go down because suddenly you had a spike in usage? And that means that, well, by saying this is deferred, it runs at a fuzzy interval. So you can say, this should run given to a couple of constraints. So, for example, when your device is charging, the user isn't using it, and you have a network connection. You could do that sync. And you don't even have to check for all these things yourself. You can do them through WorkManager. So WorkManager takes care of checking, hey, I can run this because I now have an active network connection. And also, in order to not use a lot of battery, you can actually say this should be charging, the device should be charging, so you can base your work on device constraints. So that's one of the other cool things. So you can develop other features rather than bothering with do I have network connection? Which kind of network connection do I have? Do I have enough storage to do this? What about battery? Wondering about all these things. No, with WorkManager, you just say, I have these constraints and I want to set them and just carry on with developing my features. And that's another thing that we had there from the get-go, and it's a solid feature. I'm a very big fan of that. Another thing you can do is you can have work continuations. That's one of the big concepts that you have in WorkManager. A work continuation can be done either work that runs in parallel, so things that you want to spread out and fan out over that should run in parallel. So for example, if you want to upload multiple pictures, you can do that in parallel. Say you have all these pictures selected, and you just say I want to upload them, and you can just have several workers just run with each picture, do their thing, and once they're done, and you can continue deleting the local pictures, for example. But you can also have sequential work. Sequential work means one after the other. So for example, staying with the images, you have a photo, and that photo, you take it, and then you want to apply some filters. And after you apply some filters, you want to save it and maybe upload it somewhere else. And you can do all these things step by step by step as well, either with constraints or without. And that's the two ways that you can run work continuations. Obviously, you can run a worker by itself as well, so it doesn't have to be reliant on other workers, but you can make work reliant on other work. And also you can loop in and out data, so you can pass in input data to each worker, and you can take the output data and pass it into the next worker alongside the chain. So it is extremely powerful in the way that you can actually manipulate data on the fly with while it's moving through the continuation here. Also, you can set the frequency at which work should run. So sometimes there's work that has to be run once. So say you've taken the photo, you want to upload it, and that's it, and that's just one time. Also, on the other hand, you might have things that should run a lot. So say, a sync with the backend. You want to sync that every now and then, say at least once a day, for example, you want to make sure that this runs, or if you have something that has a lot of local files, you want to clean them up every now and then, and you can say that as well. So that is the concept of one-time work, which should run once after, in many cases, a user interaction, Or on the other hand, you have work that runs many times. So you can say this should be a periodic worker that should occur every now and then until you cancel it. So that will literally run until forever, until you cancel it, or until the database gets cleared, the user clears the data on the device. We also have the concept of unique work, which is essentially schedule work that only should run, for example, periodic work, but it only should be unique. So you can add a name to it, and if a work continuation with that name already exists, then we won't reschedule that unless you specify it and all that. But it's really cool because, we had a problem where developers were saying, oh, this sync happens over and over again, and every time I restart the app, it happens once more, and that's because developers added that in their activity on create or in their applications creations lifecycle creation, and that means that every time you just say I want to add more periodic work, but by saying this is unique, that means you can say I add this, it's already there, never mind, you just do whatever you already have done. So that's another thing that we can deal with frequency when scheduling work. And you can also check for the status. So if work has completed, you can get notified of that. You can also get notification if something is in queued, whether it's scheduled, and what state the API is in, what state the work continuation is in. Back then, we thought about WorkManager as a library for managing deferrable background work. And that's technically still correct. That's what WorkManager does, what it did from the beginning, and it will continue doing that. But we also added more APIs. So there's a couple of modern APIs that we added. So one of them is for immediate work. That means that you're not only able to run deferrable work, but you can run work right now. So that means the user does something, and you can just say, OK, now let's go. I want to run this now, and it is important enough that it should be kept in the foreground, even when the device is in the background, when the application's in the background. This should still continue to run. Another thing that we added is a library, a complete separate library that helps with bigger applications to be more resource efficient with multiprocessing. That means that you have an application that actually spans over multiple process IDs. And if you ever have dealt with IPCs, that is a bit tricky. So inter-process calls, doing those things yourself, making sure that everything is properly propagated and making sure that all the things that are working together with it are in sync. This is kind of like threading, but way harder. Luckily, we have Rahul, who will talk about this later and show you how it's done within WorkManager, so you get more confidence in actually using WorkManager for this, because I think it's pretty nifty again. Another thing that we added is, who of you tests their applications, actually writes test code in either the test or the Android test directory? OK, that's a couple. Should be more than that in the end. I can show you how to do it with WorkManager. So with WorkManager, we have APIs to test your individual workers. And individual workers essentially means that you can spin up a test worker and just check what's going on, whether that is actually doing what it should be doing without having to have the WorkManager instance and actually scheduling it for work. You can test that, and you can test the entire continuation. So that means that you can actually spin up a test worker, a test work manager that you then can drive. So you can say the constraints are in the test environment are met. You can say the delays are met, and then you can check that your continuation actually does what it should be doing. And that all within the test environment. That's another thing that we added. Also, on top of that, there's tooling support. So that means we have now ways for you to better debug and inspect what's going on with your workers as they go along. If we have time and if it all works, we'll show a demo later on. If not, then I'll defer to the YouTube video. You can see a couple of minutes of seeing that, the way we do there. But there's also that support. And with all these things that are come in, we also thought about when should you be using WorkManager. And in the beginning, we said it's for deferrable background work. And like I said, it is absolutely correct that this is what WorkManager does really well, and it will continue to do that. But it is a bit outdated, because it's not the only thing that WorkManager does nowadays. So essentially, WorkManager now is the recommended solution for persistent work. And persistent is one of those words that's like, yeah, what is persistent? Persistent is not just the one word with, if you ever had your own create, there's a persistable bundle. And we essentially mean the same thing. So a persistable bundle is a bundle that persists over device reboots. And it's similar with WorkManager, where work persists across a lot of different scenarios. So persistent work, what do we mean by that? Is that firstly, your work runs not just in any scope, in your life cycle of, say, coroutines, for example, runs in a view model scope sometimes, or it can run in activity scope, or even in a global scope. This is where WorkManager runs. It runs in a global scope, so it is alive, keeps your things alive here, your work alive, as long as the application lives. But it uses, that wouldn't make it persistent. It uses the room database underneath the hood, and with that database, what it does is it keeps your work around, even if your process dies. So if your application dies and it gets restarted, that means WorkManager still knows, hey, there was work going on that I had in queued, and it just continues doing that, and it picks it back up again once your app is able to do it. And it's not just process deaths, but also device reboots. So this is what we mean by persistent work. Work will be there, so once WorkManager can do the work, it will do the work, and it will remember that the work has been there. Unless your users do something really shady, like deleting parts of the database, or you as a developer just muck about with it, which is also like, but other than that, WorkManager makes sure that this actually gets done, that your work gets done once you've scheduled it. Another thing that Rahul wanted to talk about is concept of long-running work, which we also introduced with WorkManager, and for that.
Thanks, Ben. So in WorkManager 2.3, we introduced the concept of long-running work. Long-running work is work that runs longer than 10 minutes. That's the execution window that Job Scheduler gives you. It's kind of inconvenient if you have work that needs to run longer than 10 minutes. What do you do? In that case, what WorkManager does for you is that binds the worker to a foreground service. So a foreground service is what owns the execution lifecycle of the worker at that point. And Job Scheduler and the in-process scheduler and all the other schedulers know about that job. But for all intents and purposes, the foreground service is the owner. And because foreground service need notifications, we added APIs to show and update notifications. And if you've used foreground services before, and if you're a user, you know that dismissing foreground service notifications are kind of tricky and they're not great. So we also want to make it easy for a user to cancel and change their mind if possible. So WorkManager has APIs for that. So let's look at an example. Here is the canonical example of long-running work. It's a download. I don't know how long it might take. Varies depends on network constraints and whatnot. So what we do here is let's define a few helpers so we have some context. So first thing we do is we have a notification builder that takes in some progress information and knows how to build an Android notification. Because remember, foreground services need the notification. We need to show a notification, so we need to know how to build one. Next, let's define our chunk download API. So it takes an input URL, the source of the download, an output file, which is the destination where you want to write it to, and then has a suspending download callback. And this is a callback that's called once per chunk. And so every time a chunk of the download is done, it'll give you the progress at that point. And these two methods kind of go hand in hand. You can plug in the progress information to the previous builder, to the previous helper we defined to build the notification. And finally, we can create an instance of foreground info. A foreground info is just a combination of a notification ID and the notification that we just built. Here we are creating a foreground info instance. Putting all of this together, we have our do work method, and we'll call the chunk download API with the input and outputs. And every time we get some progress, we'll call set foreground. And set foreground is what makes the worker long running. It's at that point we'll unbind the execution lifecycle of the worker and bind it to the foreground service. And then subsequent calls to set foreground will update the notification. Once it's in the foreground, it's already important. And finally, once you're done, you can return success. And at that point, we'll unbind the execution lifecycle from the foreground service, tear down the service, tear down the notifications if necessary. And all of that is kind of managed for you. And you don't really have to worry about all of that. So remember, I talked about cancellation. We also want to make it as easy as possible for you to be able to cancel one of these long-running work. So for that, we built support for cancellation. So let's look at the notification builder that I just hinted at before. So first thing we need to do is to provide the cancellation signal to WorkManager. Because if the user intends to cancel, we need a way to tell WorkManager that, hey, the user changed their mind and now they want to cancel that. So for that, the API we need is the create cancel pending intent API. This is the pending intent when dispatched will tell WorkManager that it's time to stop that work. So here we're using getID because that's the work request ID that the user intends to cancel. We'll use notification compat.builder to build the notification like we did before. We'll set some title, set some content text. And then here's is where we'll bind the notification action, which is the cancel button in the notification to the pending intent that we created. And when the user clicks on it, that's the one that gets dispatched to the foreground service already responsible for executing that worker. It's already in charge of that worker. It knows how to stop that worker. So all you really need to do is to create this pending intent, and then we'll manage everything else under the hood. With that, I'll hand it off to Ben to talk about foreground service restrictions.
Thank you. Yeah, foreground service restrictions is a new thing that we introduced in Android 12. Who of you has already heard of this? Okay, that's a few. If you've not heard of this, we are working to make sure that you can use your work in the background without having to run into restrictions here. And spoilers, it's WorkManager is the solution for that. But let me just elaborate a bit. So we have within Android 12 the concept of expedited work. Expedited, again, being one of those words that native speakers find very clear. I did not. Expedited means that you ask that this should be done, well, in a very quick way, so as soon as possible. That's kind of what expedited means, but again, let me explain a bit more. With expedited work, you can still run work from the background to be run, well, in the foreground if you have, if your app allows that, if you're currently in a state that you can do this, without having to deal with potential exceptions yourself, because that's where WorkManager does this for you, and you can use the set expedited API and just ask, hey, can you run this in the foreground? And that's one of the things that we do with this. Another thing is it's backwards compatible, because for Android versions lower than 12, you still have the possibility to set a foreground service, and you say within the worker, set foreground, and it runs in the foreground with an expedited job that might fail, and you might have an exception that I'll show you later on how to handle that. But that means you only have to use WorkManager, and WorkManager makes sure that for versions 12 and above, it uses expedited jobs, and for version lower than that, it uses foreground services and launches the entire things for you, so you don't really have to care for how this actually gets run. Another thing that it introduced is quotas. So why we do a lot of this expedited work and foreground service restrictions is not for job security, but the real way we do this is because users actually should be able to use their device as much as they want to, and they should be using the apps that they care about. And the quota that we have is basically an execution quota, where you have the possibility to run work for a specified amount of time. I know that this is very vague. If you want to know exactly how it works, you can look into the implementation, but it might change in the future. So that's why I'm not actually saying, like, this is what happens here, this is what happens there. The one thing that you need to know is that this is coupled to standby buckets. So if your app isn't used actively by the user doesn't really care about it, so the work that the app is doing is likely less important to the user, so the quota is reduced. Whereas if there is an app that is in the foreground, there is no quota applied at all because the user is actively using it. So if you're sending a chat message, for example, and attach a picture to that, say this work is expedited, there's no quota that you will be using, but it just gets executed as it would if you were to run in the foreground. But it also continues to run in the background with that, without applying a lot of quota in the first place. And that quota, like, the more frequently used the app is, the higher the quota is that you can use for your app. So one thing that you have to do, though, is you have to check whether your workers are interrupted if you want to use expedited, and store your state elsewhere and make sure that you have the possibility to recover from your app running out of quota. And one more thing that I mentioned earlier is expedited work should run as soon as possible. So that means that it's something that either should run as soon as possible it should run as soon as possible means that it is usually very important to the user that this happens now, or that the user actually initiated it. So for example, if you've got an app that is a music play service, you basically want to download music every now and then with a periodic sync on the one hand, that can use say foreground underneath the hood with like the right checks. But if the user says, I want to download this album now, then that would be expedited work that should be run while the app is actually in the foreground, and also while it's in the background, it should continue, but that's what we mean by ASAP. And these things combined are basically underneath the concept of expedited work. And this is how it works. You have a send message worker, which, and again, extended as a coroutine worker, and we now have a function for that, which is called getForegroundInfo. GetForegroundInfo is essentially the same thing as the way that Rahul just showed for how do you do the notification. It builds the foreground info, and for versions lower than 12, it creates the foreground info for you and spins up the foreground service, does all those things. For versions 12 and above, it might not show the notification at all, but you can just implement this, and you can just use that from there. And then you just implement the work function as you did before. And then another thing is, so this is within the worker, where you still have the possibility to set the foreground work service. That is as to run in Foreground. And the other thing that we have here is that you schedule the expedited work. That's part of how you actually schedule and request the work to be done. This only works with one-time request builders, or one-time requests, and you basically say, set expedited here. But it's not just a setter, but it's a setter with a policy, what happens when you're out of quota. So there's two ways that you can deal with this. So if you're out of quota, this should still continue to run, but not as expedited. So that means, well, it might run eventually once all the constraints are set and everything, but it means that it might not run straight away. Or if you think that the user doesn't care about it anymore, if you're out of quota, then it should just drop it and not care for this at all. So it just doesn't run this work at all. So that's both of those ways that you can deal with this. But going back a bit further is how does WorkManager deal with work? There's two different ways that WorkManager does this. One of them is one-time work. That's, like I said, it just happens once. On the other hand, you have periodic work. And a periodic work is, well, things that happen over and over again until you cancel them. And all of those are deferrable. So that means that everything in here can run later at any given point in time. They both can also be long-running. So that means that this work can use a foreground service and run for a long, long time, for longer than 10 minutes, as we said earlier, but only one-time work. It runs a foreground service, but only one-time work can run immediate. So that means that this is only the only one that can run expedited. So periodic work and immediate is kind of opposite. So you can't just say, like, this should run at given intervals, but right now. So you still have the initial delays that you have on this. And for all the versions in 12, this runs a foreground service. And how do you do this is you say set foreground in here, in your worker, and you get the foreground info that you passed in earlier. Instead of passing in a parameter here for the notification that you want to change there, you just have to hold on to this somewhere else in your worker, but it essentially works the same way. And then you just wrap this in a try-catch block. For versions older than 12, you have the illegal state exception, and if you catch an illegal state exception, if that happens, then you just do your cleanup work, and you fail the worker, and that's it. And for versions newer than Android 12 and from 12 and above, you can do the foreground service start not allowed exception, which is essentially an illegal state exception, so you can handle that and make sure that you're actually just handling this one exception, and if it doesn't work, you just fail, and that's it again. So with this in mind, this is the part where it's all about workers. This is where you implement things within your workers themselves. And then you can say set expedited within the work continuation. And then again, under Android, like for versions lower than Android 12, this might use the foreground service. So with all these things in mind, this is how you can schedule work with WorkManager. And we will soon add that to our reference documentation as well. So you can see this coming on there as well. We also have it in the videos. And once this video is live as well, you can see how this works. And this is basically how WorkManager deals with your work, and this is how you can also schedule expedited work here. So essentially, the worker is the thing that can run in the foreground, whereas the work request is the request that you can expedite. So those are the two different concepts that you have to keep in mind for this. So they're not the same thing, they're not interchangeable, because only the worker knows whether it should run in the foreground, because it might be long-running, like download might be long-running, but the work itself is the work that should be expedited. So if you think the user actually thinks that this is important, then this is where it should be expedited, and that's where the work request comes in. And with that, I'll hand back off to Rahul for another really cool feature, which is multi-process support.
Thanks, Ben. We've been working on multi-process APIs for a while now, and I'll set some context on why we need special APIs for multi-process. So the first thing we need to do is we need to define a dependency on the work multiprocessing artifact if you want to use any of the multiprocessing APIs. And the goals of the multiprocessing APIs are twofold. First, we want to avoid any expensive bits of initialization in secondary processes. We'll talk about that in more detail. And then we also want to improve resource efficiency. So we want to make sure that the in-process scheduler is running in the right process. I'll talk about that in more detail also. And we also want to reduce SQLite contention when there's more than one process trying to write to the same underlying SQLite data store. So to understand what parts are expensive, let's just recap what happens when you initialize WorkManager when you only have one process. So first thing that the platform does is it calls application on create. At some point in the process lifecycle, we'll call WorkManager.getInstance. This is when WorkManager is being initialized. So when WorkManager is initialized, we'll run for-stop runnable. This is a very important bit of initialization. What happens here is WorkManager will check if the app was previously for-stopped, and if it was, then it'll reconcile the state of the work request that it knows about, and it'll compare and contrast it with what job scheduler and or allow manager know about, and it'll make sure that they're one and the same. This is very important for your app, because if they're not, then some of your work requests went missing, and that's not good. So this is also the time where we'll also reschedule interrupted work that may have been interrupted because of a process crash for an unrelated reason. So your app might have had a bug, and the worker may have crashed as a result of the process crashing, and so we'll recover that kind of work transparently without you having to do anything about it. And this is the process that the in-process scheduler runs in by default. Because there's only one process, that's the right process for us to run the in-process scheduler in, so everything looks good. Now let's look at multi-process in it. So in the first process, we initialize it as before. This is the process that the in-process scheduler runs in, like we talked about before. In the secondary process, we'll run application onCreate again, because application onCreate, remember, is called once per process and not once per app. And then at some point, WorkManager.getInstance is called, and then we'll run the expensive bits of initialization again. So this is called for-stop runnable again, which is, you might be wondering why. We just did it in the previous process. The reason why we have to do it anyway is because we don't know which one of these processes are actually important for the application. Your application might be a widget, or it may be a keyboard. And we don't know which one of these processes are long-lived. So we don't know which process to run for-stop runnable in, because we don't know which one of these is more important. So we'll just do both. And because the in-process scheduler can only run in one process, it'll run in the default process by default. And if this is the less important process from the perspective of the application, then this can significantly disadvantage your app's throughput, because you'll execute far fewer workers than you can. So you don't get the in-process scheduler. So for the first thing you need to understand is you need to make sure that the in-process scheduler is running in the right process. For that, you can override the default process by using configuration.builder. The API is set default process name. This is the process that the in-process scheduler runs in. And that's all you need to do. This is typically the app's package name. So that's the name of the process. You might be wondering if there's a way to completely avoid the expensive bits of initialization. So what if I don't want to run for-stop runnable in the second process? What if I just want WorkManager to initialize in one process? For that, we introduced a class called Remote WorkManager. And what that does is it binds to the designated process that you configured, and then forwards all requests made in the secondary process to the primary process by using by using a bound service. And that way, what's happening is WorkManager doesn't need to be initialized in the secondary process at all. We'll use the first process, and then we'll avoid all SQLite contention altogether, because that's the process that's writing to the underlying SQLite data store. So we kind of optimize for resource efficiency in both phases. And using Remote WorkManager is pretty easy. You create the work request like you did before, and rather than call WorkManager.getInstance, you call Remote WorkManager.getInstance. And it's at this point that we'll bind to the designated process. Send the request over using idle, and then we'll enqueue the request in the primary process. So as you can see, this binds to the designated process, and everything's good. And the way this works is we'll manifest merge. So when you add the dependency that we talked about, which is the work multiprocess dependency, we'll manifest merge this service called Remote WorkManager service to your app's Android manifest.xml. And that's the service that WorkManager uses to bind to. So when you use Remote WorkManager APIs, that'll be the service that we bind to. Now, sometimes that's still not enough. Sometimes what you might want to do is you want to run your worker in a different process. And the reason for this is that you may have an important UI showing a process that's responsible for showing the user interface, and you want to isolate any risky use of APIs from that process, because you don't want that process to crash. You can afford other processes crashing because the user doesn't really know that crashed. So you want to offload some of your work to a less important process. So to do that, we actually let you run workers in a less important process. So for that, all you need to do is to swap the class that you're extending from coroutine worker to remote coroutine worker, and then you just implement do remote work instead of do work, And then that's the method that runs in the secondary process. And the way this works is you need to add this entry to your Android manifest.xml. This is remote worker service. And you tell which process you want this worker to run in. And here we're saying that this worker needs to run in a background process. And now that we define the service that needs to be used to run the worker, we still need to tell WorkManager that this worker needs to use that service. And so for that, we need to specify the component name. A component name here is just a combination of a package name and the service name that we want WorkManager to bind to. So we'll define that as input data, and then we'll create the work request like we did before, and we'll call getInstance. And it's at this point that WorkManager knows which component to bind to. It'll create a bound connection to that service, and then teleport your worker to that process, run the worker, take the result and bring it back to the process where the worker should have run in. And then all of this is being managed behind the scenes without you having to worry about it. And then we'll even tear down the service correctly at the right time. So all of that is managed for you. So I've touched upon why it's important to run the in-process scheduler in the right process, and let's talk about why it's really, really important. And so what happens is, this is the life of a work request. So when you create a work request, we'll fan that work request out to multiple schedulers. There's at least 2 schedulers at any point in time. There's the in-process scheduler, and this is running when the process is up. And then there's the persistent scheduler. This is running or keeping track of work even when the application is not running. A canonical example is Alarm Manager or Job Scheduler. Now, persistent schedulers suffer from a disadvantage in that they usually have scheduling limits. So Job Scheduler famously has a 100 job limit. Alarm Manager has a 500 alarm limit. And they very unhelpfully fail with the opaque illegal state exception when you try and create the 101st job. And I'm sure you've run into this before WorkManager existed. The reason why you don't see that anymore with WorkManager is because we are very, very strict about scheduling limits. And that's totally configurable. We choose a very conservative limit of 20, but you can go up to 50 jobs. So the reason why this is important is, as I said, Job Scheduler will only let you schedule up to 50 jobs. The maximum scheduling limit that WorkManager will allow is 50. You might be wondering why it's not 100. That's because of a really interesting Job Scheduler quirk in API 23, where Job Scheduler prefers batching of work, and even though the constraints are met. So if you have a single worker that's waiting for a network constraint, Job Scheduler will wait for at least one other worker to have that constraint for it to run that work. And that's not ideal because ideally your worker should have run already. And so we work around that by double scheduling work. So we maintain a batch size of 2. So that's why we have a limit of 50. And so you have all these really odd quirks that persistent schedulers have. Now, the in-process scheduler doesn't actually suffer from any of these limitations. It can execute work as quickly as it can because the process is already up and running. You're really only bottlenecked by the size of your thread pool. So you can run a lot more work by running the in-process scheduler. And all these schedulers will eventually delegate, once the constraints are met, they'll delegate to an entity called the processor. And the reason why we have a special entity to run work is because different schedulers may reach out to WorkManager at different points in time. The in-process scheduler picks up work very quickly. Job scheduler might decide to defer your work for a little bit, and 10 seconds later, it may say, okay, now's a good time to run that work. Whereas the in-process scheduler might already have picked up that work. So we want to dedupe these requests to run the same piece of work over and over again. So we have to maintain some level of guarantees that there's only one copy of your worker that's running at one point in time. So that's why we have a processor. The processor eventually creates a runnable called worker wrapper. This is, again, responsible for things like input merging. So if you have multiple prerequisites, we'll do input merging. We'll make sure that the worker's in the right state. We'll make sure that the constraints are met again. And then we'll finally dispatch to start work. So when you create a single worker, this is all of that. This is all the machinery that's running behind the scenes to make sure that your worker gets a good chance of running. And this is why running the in-process scheduler in the correct process is super important. It's the difference between you being able to run 50 jobs versus unlimited, right? So, and then the workers and the schedulers kind of cooperatively notify each other. So when you're done, you tell, you signal success or retry or failure, and then WorkManager's responsibility is to communicate to the scheduler and tell it, So when you retry, we'll need to tell the scheduler that it needs to create a new job, and the worker's not done yet. And then the scheduler can also notify the worker that it's time to stop because your constraints may be unmet. The conditions on the device may have changed. So there's like a lot of cooperation between the scheduler and the worker. With that, I'll hand off to Ben, who can talk about Hilt integration.
Thank you. We don't have time for a demo, so I'll quickly just brush over the Hilt integration before we maybe have some time for questions. Hilt is our dependency injection library based off of Dagger. So if you use Dagger and you wanted to make that easier for Android development, Hilt is your answer. And one of the cool things working with Jetpack libraries is that a lot of those work together. No pun intended in this one, they actually do. And Hilt, it has a library, which is the Hilt work library, which essentially makes instantiating and injecting into workers easier. To use it, all you have to do is, well, we have to first disable your default configuration. And default configuration is the way that we manifest merge when you use WorkManager into your Android manifest. And you do this by removing the WorkManager initializer node, and then you have to configure WorkManager at runtime yourself. To do that, you implement the configuration provider, you add the Hilt worker factory in this case, and in your Hilt Android app. And then you say, in your WorkManager configuration, you set the worker factory. You create your builder, you build it, and then you have your configuration, and then your application can use, in this case, Hilt for WorkManager. It might be that you have already a configuration in place for, say, you already have a worker factory, and that's where you can use a delegating worker factory instead of having just one worker factory, but multiple of these. So that means that a worker factory essentially is where WorkManager looks up how the workers should be instantiated. And if you have renamed worker, then you need something like a rename worker factory, so WorkManager can look up where workers are, and if they have changed name, then basically that's how that works, because it's stringly typed at that point. Because of the way that it's written in a database. I could go into detail, but we don't have the time for that, I'm sorry. But essentially with the delegating worker factory, what you do is you add multiple worker factories that you have, and you add all of these, and the delegating worker factory then just checks if any of these can instantiate your worker and run your work afterwards. And then you just build that the same way you did before, but with more than one worker factory, which is pretty nifty. And then you just create your worker as you did before, but add a couple of nice shiny annotations. Say this is now a Hilt worker. You set your assisted inject on a constructor. You're assisted on your parameters. And now you can have your worker instantiated with Hilt rather than doing the injection yourself. Pretty cool. That's not the only way that Hilt helps you, but it's one of the ways that it helps you with WorkManager, and that's why it's important here. This is just very, very quickly how you can take a look at WorkManager's Android Studio integration. So if you ever wonder what's going on with WorkManager underneath the hood, you can open App Inspection. App Inspection, you hit Shift twice for my favorite shortcut in Android Studio, which opens this dialog. And then you just type App Inspection and hit Enter. Or on the other hand, you open View and click on Tool Windows and then on App Inspection, and that's how you open that. It's a window that shows you what's going on in your database, what jobs are running and all that. And if you kick off work, you can use the sample that we have on GitHub for this. You can just see what's going on with the workers as they go along the chain. You can play around with different views and all that. You can also watch the other recording of this talk to give you a bit more info. And it's really nice to actually see how workers are doing things under the hood. Also, all the debug logs that you might set, you can search them in ADB by just looking for the prefix WM-, so WorkManager for short, and you can see what WorkManager is doing, what state your worker is in. So those are two different ways that you can actually see and debug and inspect what's going on with your workers as they go along. It works both for stuff that is live as well as for your tests as well. We're dropping the demo, but there's more. The things that you can learn about WorkManager is we've got videos available, we've got code labs available, we've got documentations and samples. Thank you very much, and I think we'll be around for questions.